Hey, how is it going everyone? Welcome to Cyber Hashira. In the previous video on OpenSSL, I talked a bit about integrity, which is a technique used to detect unwanted changes to a data. We achieve it using hashing algorithms such as MD5, SHA-1, SHA-2, SHA-3, and there's many more. In this video, I'll talk about confidentiality. I'll teach you how to use OpenSSL to achieve it. Let's see how it's done. A secret information is called confidential, and to keep that information secret is confidentiality. Using cryptography, you can protect confidential information by encrypting it, thereby achieving confidentiality. To encrypt, you need keys. So first, I'll show you how to generate keys, which later can be used for encryption. I'll start with symmetric keys, also known as secret keys. To generate secret keys in OpenSSL, you can use a command in OpenSSL called rand. So if I execute OpenSSL rand-hex, and if I mention the size of data, for example, I'll just say 10. So this is 10 bytes of randomly generated data in hex format. Similarly, if I want to generate another data, for example, I'll just mention 16. This is 16 bytes of randomly generated data. I can even output this data into a file. So I can execute the command OpenSSL-rand hex and then -out, and I'll name it, for example, encryption.key, and the size of data, for example, 32. I'll hit enter, and here's our encryption key. Now we can use this key for encrypting any data that you want. I'll clear the screen. And now I will show you how to generate asymmetric keys or private keys. For this video, I will use RSA keys as an example. I will make another video on asymmetric keys where I will elaborate more on generating asymmetric keys using OpenSSL. To generate RSA key, I can simply execute OpenSSL and gen RSA. So this is a RSA private key. It is 2048 size in length, and the exponent is 65537, and this is the actual private key data. All right, I'll clear the screen. If you want, you can even mention the key size. For example, I can do OpenSSL gen RSA 1024. This is an RSA key with 1024 size. Similarly, I can do gen RSA 2048. This is another private key with 2048 bit key size. I can even output these files onto a file. So for example, if I do OpenSSL gen RSA, and I'll just call it key.pri. PRI is for private. I mean, it's just an extension that I use. And now if I do cat key.pri, here's our private key. There's also a function. So if let me remove key.pri. There's also an option in OpenSSL to output this key. So I can do OpenSSL gen RSA-out key.pri and the key size, for example, 2048. And now if I do cat key.pri, here's our private key. Okay, clearing the screen. Once you have generated a private key, you can examine that private key using OpenSSL RSA-in and the name of the key. For example, in my case, it's key.pri no out-text. This is going to produce a long but a very detailed output. So we can see that this is an RSA private key of size 2048. This is the modulus, and this is the private exponent. There are two prime numbers, and there's exponent and the coefficient. Private keys are generally used to sign some data or to decrypt a data. We need, so right now we just have the private key. We also need public key if we want to encrypt some data. And to do that, the command is OpenSSL rsa-in, and the name of the file is key.pri. This is our private key. I'll do pub out, and then out. I'll name it key.pub. Now if I do cat key.pub, here's our public key. And now this public key can be used to encrypt some data. All right, I'll clear the screen. Now that I've generated my keys, my next step is to determine the encryption algorithm to use. OpenSSL has plenty of options. I'll show you how to get the list of all available algorithms in OpenSSL. So there's an option in OpenSSL called list. If I add commands, these are all available commands in OpenSSL. Similarly, I'll clear the screen. If I run the command OpenSSL list dash digest algorithms, these are all digest algorithms that are available in my OpenSSL. Similarly, I need the list of all ciphers. So I can do cipher algorithms. And these are all cipher algorithms that are available in OpenSSL. OpenSSL list dash public dash key dash algorithms. And these are all public key algorithms. I can also use OpenSSL list command to get more information about the usage of an algorithm. So for example, if I do OpenSSL list dash options, and I'll do AES256 CBC. Now these are the options that will be used with this algorithm. And now I will show you how to encrypt file using OpenSSL. In my current directory, I have 4 files. I have earth.txt, which is it's just a text file. I will be encrypting this text file using the keys that I've generated. So I have a secret key, encryption.key, key.pri, this is my private key, key.pub, this is my public key. So let's use AES algorithms. So AES-256 CBC. Input is going to be the file that I want to encrypt, which is earth.txt. Output is going to be the file which will store the encrypted data. I'll change the extension to ENC just to denote that it's an encrypted file. -E is for encrypt. -K file is for the encryption key. Hit enter. I'm getting a warning over here. However, I do have my encrypted file. This is my encrypted file. If I do cat on earth.enc, I don't see anything. Obviously, this is a binary file, and I can't simply print a binary file, but that is so earth.enc is an encrypted file. I'll clear the screen. Let me show you how to decrypt this file. So same command, OpenSSL AES256 CBC. I'm going to take earth.enc as the input. This contains the encrypted file. Output is going to be earth. I'll change the extension, or I'll use DEC as the extension. So DEC is for decrypted, and -D is for decrypt. -K file is for the encryption file or the encryption key. Hit enter. I'm getting a warning, but I do see earth.dec. And if I view the content of earth.dec, I have the decrypted data. Let's see if it matches with the original file. Yes, it does. I'm going to use a different algorithm this time. I will use des3. So the command is OpenSSL des-ede3 cbc. Input is earth.txt. Output is earth.enc. I want to encrypt, and -a. Let me explain this command. I want to use DES3 algorithm to encrypt earth.txt. Output is going to be stored in earth.enc. -e is for encrypt, -a. Now in the previous command, the encrypted data was written in earth.enc in binary format. Instead of binary format, I can use -a option to tell OpenSSL to write that data in base64 format. And that's what I'm going to do here. Also, I am not passing -k file option. Let's see what happens. So if I don't use -k option, it will ask me to enter a password. So I will enter a password. And obviously I'm getting a warning. So if I don't pass -k file to enter an encryption key, OpenSSL will automatically prompt me to enter a password. The password that I enter over here will be used by OpenSSL to derive a secret key. And that secret key will be used to encrypt earth.txt. So if I do cat earth enc, I see the encrypted data. So this is the encrypted data in base64 format. Let me show you how to decrypt this data. So to decrypt this, I will do OpenSSL, or I can just bring the same command. I just have to change the name of the file. So this will become enc, and I'll change this to dec for decrypt. This will become D is for decrypt, and -a means the input is in base64 format. Hit enter, and I will enter that same password. I'm getting a warning, but the file has been decrypted, and this is that plain data. Let me show you what would happen if I enter a wrong password. So I'll bring this command again, and this time I'll just enter a wrong password, and I'm getting an error over here. Now the password that I entered for this command, that password was used to derive a secret key. However, the secret key that was derived with this password is not the same that was used to encrypt earth.txt in this command. And that's the reason why the decryption fails and we are getting this error message. I will now use password-based key derivation format. So the command is OpenSSL AES256 CBC. Input is earth.txt. Output is earth.enc. I want to encrypt this file. I want the encrypted file in base64 format, and I want to use my key file, which is encryption.key, and I want to use password-based key derivation format too. I'll hit enter. Let's have a look at earth.enc, and here's the encrypted file. Now you must have noticed here, because I'm using password-based key derivation format 2 option, I am not getting any error message. Let's try to decrypt this file. So OpenSSL AES256 CBC. Input is earth.enc. Output is earth.dec. I want to decrypt. Encrypted file is in base64 format, and the key file to use is encryption key, password base key derivation format 2. I'll hit enter. No errors. Let's do cat on earth dec, and here's our plain data. Let me explain what PBKDF2 does. Password based key derivation format is a way to derive a secret key from a password. When I enter my password, OpenSSL will calculate a hash of my password and then mix it with some randomly generated data called salt. It would then hash that salted data again to derive a new secret key. Now this process is repeated multiple times. By default, OpenSSL uses 100,000 iterations. The secret key derived from this process is very hard to crack or even brute force. This makes password-based key derivation format 2 significantly secure compared to just using a simple password with no -PBKDF2 option. That's the reason why OpenSSL recommends using -PBKDF2, and it shows a warning when you're not using -PBKDF2 option. There is another option which I can use to specify the number of iterations. Let me clear the screen. To specify the number of iterations, I can simply, where's the previous command? Okay, I can simply add -iter and mention the number of iterations. So for example, by default, OpenSSL has a default iteration of 100,000. So I'll just mention 10,000 now. That's it, done. And if I want to decrypt, I just have to add the same number of iterations again, and I should have my decrypted file. Let me show you what happens if I mention a wrong iteration. So for example, instead of 10,000, I'm going to mention 5,000, and I get an error. I am getting this error because the number of iterations that I mentioned over here, 5,000, is obviously going to produce a different secret key, and that secret key is not the same secret key that was used to encrypt earth.txt. And for that reason, the decryption fails and I get this error message. There's also another way to perform encryption and decryption, and the command is OpenSSL enc, which is for encryption, and then I can simply specify the algorithm that I want to use. So I'm going to try something different this time. So I've been using CBC. Let's use CTR this time. So -AS-256-CTR, and it's the same syntax. I have to pass an input file, which is earth.txt, and an output file. So I'll put the output in earth.enc. I want to encrypt, and I want a base64 output. I want password base key derivation format 2 with an iteration of let's say 2000. I didn't pass the key file. Oh, never mind. I'll just enter my password. Okay, and the encryption has completed. So if I look at earth.enc, here's the base64 encoded encrypted data. Similarly, if I need to decrypt this data, I would execute OpenSSL enc AS256-CTR. Input is going to be earth.enc and the output is going to be earth.dec. I want to decrypt. The data is base64 PBKDF2 with an iteration of 2000, and I would enter my password. It's the same password that I use for encryption. And if I have a look at earth.dec, here's my clear data. Now I will show you how to encrypt and decrypt data using RSA keys. So the command is OpenSSL RSA-UTL encrypt. In key is my public key. I need public key for encryption. I also need to tell OpenSSL that the key that I'm passing as input, it's a public key. If I were to pass a private key, I don't have to specify this option. So pub in, and the input is going to be earth.txt. Output is going to be earth.enc. I'll hit enter. And to decrypt, I can run the command RSA-UTL decrypt. In key, this is going to be my private key. I don't need pub in because the key that I'm passing is a private key. Input is going to be earth.txt. Output is going to be input is going to be earth.enc, and the output is going to be earth.dec. Cat earth.dec. Here's my clear data, and let me show you the encrypted data as well. and this is the encrypted data. Obviously it's in binary format, that's why we are getting this garbled text. And yeah, so that's how we encrypt and decrypt using RSA keys. There is something about RSA keys that I think you should know. Although RSA keys are allowed to encrypt and decrypt, they're not suitable for encrypting a large amount of data. The data that I've been trying to encrypt was just a few bytes in size. By default, OpenSSL would use PKCS1 padding scheme to pad data before encryption, and PKCS1 has a size limit. Let me show you. I'm going to bring an RFC doc. So we are looking at RFC 2313. This is the link. I will put this in the description. This RFC is all about PKCS1 padding for RSA encryption. And if I scroll down to section 8, okay, here's section 8, and here it is. The length of data D shall not be more than K minus 11 octets. Now, this means that if the RSA key that I'm using is of size 2048 bit or 256 bytes, then the maximum size of data that I can encrypt will be 256 minus 11, and that becomes 245. Let me show you. I'm going to minimize this. So as per RFC 2313, if I'm using a key size of 2048 bit, which is equals to 256 bytes, I would subtract 11 bytes, which are reserved for PKCS1 padding, and we get 245. So this is the size of data that I can encrypt using RSA 2048 bit key. Let's see, let's test this out. To test this, I'm going to generate some random data. So OpenSSL rand, and output is going to be data, and the data size is 245. I'm going to encrypt this 245 bytes of data using RSA public key. So OpenSSL RSA UTL encrypt, and the input key is going to be key.pub. It is a public key. Input is going to be my data, and the output is going to be data.enc. And encryption works. There is no error. Let's see what happens if I increase the size of data. So instead of 245, I will now use 246. So I have just generated 246 bytes of data. Let's try to encrypt this data with the same command, and I get an error. This error clearly says that it is related to PKCS1 padding, and the reason it says that the data is too large for the key size. And this proves exactly what is written in that RFC document. A practical way to use RSA keys is for key transportation. You can use it to encrypt a secret key. For example, I have my encryption key. I also have a private key and a public key. Imagine that this public key was given to me by someone else. I can use this public key to encrypt my encryption key, and also I can use my encryption key to encrypt earth.txt. So to encrypt the encryption key, I would use the command OpenSSL RSA UTL encrypt, and the key is going to be key.pub. It's a public key. Input is going to be encryption key. Output is going to be encryption key.enc. And now I have encrypted my public key, encrypted my secret key. Now whoever has the private key should be able to decrypt my secret key using OpenSSL RSA UTL decrypt. In key is going to be the private key. Input is going to be encryption key.enc, and the output is going to be encryption key. You can name it whatever you want, so I'll just name it encryption key.dec. And the encrypted secret key has been decrypted. So here's the decrypted secret key. That's about it for this video. I've taught you how to use OpenSSL for encryption. I'll upload all my notes to my GitHub page. Link will be in the description below. My next video is going to be about asymmetric keys such as RSA and ECDSA. And as always, thanks for watching. Be sure to subscribe to my channel and don't forget to like this video if you liked it. I hope to see you soon in my next video. Take care.